In today's lecture, we'll learn to draw the layout of a 3-input NOR gate. At first, open the terminal window by pressing Ctrl, Alt and T. So this is our terminal window. Type magic. So this is our layout window, and we have to type the commands in the tick-icon window. First, clear all other commands present in the tick-icon window. Type clear. Okay, now we can see there are no boxes present here, so we have to first grid it. So type grid. Now at first we have to create the anvil region, so we have to select the area. Since this is a 3-input NOR gate, so we should keep the anvil in a larger area, and next also the P diffusion layer. So left click and then right click. There will be 3 poly layers, so 1, 2 and 3, so we need a bit bigger one. Now we have to type paint anvil. So the anvil layer is drawn. Next, it's not visible, so let me zoom in. Okay, Shift Z. Then next, select the area for the P diffusion layer. Type paint P diff. This is the P diffusion layer. Next is the contact. Okay, now type paint. Okay, before going for this, we have to create the metal layer over here for VDD. So select the area and type paint M1. Okay, now from here type paint M1. Okay, next we have to place a contact. Type paint. Since this is our P diffusion layer, so P diffusion contact, PDC. Okay, now next we have to create N diffusion layer. So select an equal area and type paint end diffusion, that is paint end diff. So this is our end diffusion layer. I think this became too much. You can see the width of the P diffusion layer. So similarly, this should be less in the same width. So this got erased with the help of erase command. Now we have to make a poly contact. Before poly contact, we have to place a metal layer over here also for the ground. So select the area, then type paint M1. Okay, so this is the ground layer. Now next, suppose I want to move these two a bit upwards. So I can do that with the help of the command move. So for that I have to select the area. Okay, I'll type select area. So select area. Okay, then move up 10. So this got moved up by 10 cells. Now if I type here select area, so you can see after executing the command only this area has been selected. Move up by 5. Okay, now after this I have to select the area and then type paint M1. Then next the poly layer. Okay, this became okay, paint poly. Now you can see we can just increase the width of this metal layer. This is too much, so type paint M1. Now in order to place the end diffusion contact, select the area, then type paint NDC, that is end diffusion contact. So for P diffusion contact is used in case of P diffusion layer, end diffusion contact is used in the case of end diffusion layer. Now press enter. So you can see the two contacts placed. Just in order to make the uniformity, I'll increase the M1 layer. This won't cause any problem even if the present length, the present width is there. That won't cause any problem, but just in order to keep the uniformity, we'll increase the width. Paint mm. Okay, now we can remove this extra layer by typing erase. From here to here, type erase. Okay, now next, yes, we have the metal layers, right? So we have to place some more contacts. I'll erase this one. Okay, now I'll place some more contacts in the metal layer, that is the NWC contacts. So in order to do so, we have to type paint NWC. NWC refers to N-well contact and PWC refers to P-well contact. So here we have the N-well and we will place here the N-well contact. Select the area and type paint NWC. We'll place some more. Okay, you can see the selected area is shown every time we left click the mouse. Paint NWC. Type paint NWC. Okay, now if we want, we can remove the excess region. Select the area and then type erase. Similarly, over here we have to place the P-well contact. Select the area, type PWC. PWC. Select the area and erase. Okay. Now next, we have to place a contact over here. Before that, we can create a poly region. Type paint poly. Okay. Now next, there will be another layer over here. Okay, we'll directly select from here and then type paint M1. Okay, just increase the length. Okay, now select the area. Paint NDC. Okay, now next there is another poly. Type paint poly. Okay, now since this is a 3-input NOR gate, certainly there will be 3 PMOS and 3 NMOS, and the gates of the corresponding NMOS and PMOS will be shorted. So this 3 poly resemble the 3 shorted gate terminals. Now this is our VDD and this is our ground, and from here, since this is a since this is the NOR gate, so we'll selected the area, then type paint M1. Correspondingly, select the area and type paint M1. From here, and then type paint M1. Just we need to extend one more layer. Paint M1. Okay, now we have to place the contacts over here. So select the area, and then type paint. Since this is your P diffusion layer, we have to type PDC, and these are your N diffusion layers. So type paint NDC. NDC. Okay, now these are our 3 inputs A, B, C. This is our output that has been shorted in this manner. Okay, and this is the metal layer, that is the VDD, and this is the ground. Now since this is a 3 input, this is a 3 input NOR this is a 3 input NOR gate. these are our PMOS. So a single PMOS source level go to VDD, and these two will go to ground, and the NMOS, this is our NMOS layer. This shows our NMOS gates, and these two will be shorted. So we'll try to label it. We'll label it. How we can label it? Just take a square, right click over here, then type label VDD exclamation. So you can zoom it. You can see the VDD layer. Okay, now select a square, right click, type label ground. Ground has been labeled. Next is the turn for ABC. Label A. This will be label B. This will be label C. So these are the three inputs. Now this one is the output. So we have to type label out. After the naming part is done, we have to save it. We have to type save. This is our node 3_1. Let me type once more. Save node 3_1. So now you can see loaded node 3_1. Okay, this is our SCMOS. Now we have to extract it. Next array city extract. So we have extracted node 3_1 into node 3_1 dot ext. Next, extract to sim. Extract to sim finished. Extract to spice. Now let's see the layout of a 3-input NOR gate that is drawn from the untwisted schematic. Now open the terminal window by pressing Ctrl Alt and T. Then type magic. Then press enter. Now this is the layout window and this is the tick icon window. So at first we will draw the layout without using the commands, directly using the toolbar. So go to options, then click on toolbar. So you can see all the toolbars over here. Now in order to grid in, press G in your mouse. In order to zoom in, press Z. So in a 3-input NOR gate, The function is a plus b plus c bar, that is the PMOS, the NMOS is in parallel and the PMOS is in series. So first we have to draw the PMOS. Since the PMOS is in series, let's say this is the anvil. So middle click on this, or we can do one thing directly. We can take different anvil and P diffusion, or directly in one we can take. Since we are doing the untwisted schematic, we can even take it directly. The PMOS can be taken directly since they are in series. Okay. Now after selecting the area, middle click on the anvil. Okay, then we need the P diffusion layer. Select the area, then middle click on P diffusion. Okay. Now draw the corresponding gates. So this is gate 1. This is gate 1 and middle click on poly. This is gate 2. This is gate 2 and this is gate 3. Okay, gate 1, gate 2 and gate 3. Now the first PMOS has its source connected to VDD. So select the area and then middle click on the metal layer. Again middle click on metal one. So this is your VDD. The source of the first PMOS is connected to VDD. Then this is the drain and drain of first PMOS, source of second PMOS. This is drain of second PMOS and source of third PMOS. This is the drain of third PMOS. Now the drain is connected to the drains of the three NMOS. So we have to draw the NMOS. So select the area. Okay, first take one in middle. Okay, now middle click on the end diffusion layer. Similarly over here, then another over here. Middle click on end diffusion. So 3 P diffusions and 3 end diffusions. You can take one thing, don't need so much of area, so we can remove it. Now next task is to connect the corresponding, this is corresponding gates. This is A will be connected to this one, So select area and then middle click on this one, remove this, then click on poly, so this is A. Now B is connected over here, C is connected over here, so we'll remove this portion. Okay, then middle click on poly, from here to here, then middle click on poly, then we can connect from here. Poly, this is A, B and C. Now these are the common portions, that is common source drain, but this is the drain terminal, these three are drain terminals, these three are the source terminals. So the source of the NMOS is always connected to ground. So select the area, middle click on M1, then zoom it and see how much is the width. It's 5. Middle click on M1, middle click on M1, similarly over. Okay, now these are connected to ground, these three will be zoom it and see how much is the width. 1 2 4 5 6. Okay, then middle click on M1, M1. Okay, the drains are shorted, all shorted. So you can see the circuit is very simple. Now I have to place the contacts. So this is a P diffusion contact. So middle click on PD contact. One, two, three. Okay, we made this 6. Should have done 5. That was 6 cross 6. This is 5 cross 5 PD contact. Similarly, we have to place the N diffusion contact. N diffusion contact. Similarly over here, then click over here, then This is the ND contact, same as here. Okay, after placing the P diffusion and diffusion contact, we have to place the P substrate contact and the N substrate contact. Now click on P substrate contact, then one here. Okay, this should be P substrate contact. P substrate contact, similarly one over here. Now in the similar way we have to place the N substrate contacts. We can place two. Okay, now time labeling. We have to label. This is A, input A, so we can do like this. Put some extensions. And this is the output. This is metal. Start with VDD. So left click, right click, and right click. Label VDD. This is ground. Label ground. Label VA. Since this is a 3 input, this is B. Label VB. This is C. Label VC. And then we have V out. Label V out. We can remove this extra portion. Then save it as NOR 3. Actually this is NOR 3. Okay, NOR 3 saved. Then find the DRC errors. No DRC errors. Then extract exe file generated. Extract to sim. If required, then extract to spice. So all the files generated. Now time to execute the sim file. So it's simnor3.sim. Then watch W, VA, VB, VC, and V out. Display D, we'll get all the values as X. Then since this is a NOR gate, let's give low value to all VA, VB, and VC. L stands for low and S to create a step function. When 0, 0, 0, NOR output is 1, the invert of the OR. Then for 0, 0, 0, the output will be 1. For any other values, the output will be 0. So let me give high value to VB, suppose, then S will get 0. High value to VA, then give a step function, again it's 0. high value to VC, 0. If I give low value to VA and then give a step function, still 0. Only in a case where all the three are 0, we get output as 1. If you want to see it in an analyzer, ANA, VA, VB, VC and Vout. You can see over here 0, 0, 0, output 1. In any other case where any of the input is 1, your output is 0. Again 0, 0, 0, output is 1. So this is the waveform of a 3-input NOR gate. If you want to exit, type exit. Want to see your layout again, type magic NOR3.mag, that's the extension. So this is the layout of a 3-input NOR gate that is drawn from the untwisted schematic without using commands, that is by using the toolbar. Now let's see the layout of a 3-input NOR gate that is drawn from the twisted schematic by using the toolbar window. Open the terminal window by pressing Ctrl Alt and T. Now type magic Now this is the layout window and this is the Tikicon window. Now in order to grid in, press G in your keyboard, then press Z, go to options and click on toolbar in order to load the toolbar. So if you want to draw the layout from the twisted schematic, then it's very easy for you to draw the layout. So first we have to draw the PMOS, then the NMOS. Since the PMOS, this is A plus B plus C bar, that is A plus B plus C, that is OR, the OR operation. There's a PMOS is in series and the NMOS is in parallel. So when there's a series connection, then we can place one whole N well at a time. So middle click on N well and then in one we can place all the P diffusion, then middle click on P diffusion layer, this is the P diffusion layer, this is P diffusion 1. So select the area and then middle click on P diffusion 1, P diffusion, sorry, this is the N diffusion layer, so N diff. Then this is the second one, then middle click on N diffusion, then we'll click on N diffusion. Okay, now since the three NMOS are in parallels, we have placed them separately. Now place the poly layer and then middle click on poly. Similarly over here, middle click on poly. And over here also. So these are three inputs A, B and C. Now this is the source of PMOS1. This portion is drain. This portion is source of PMOS2. This is its drain. This is a source of PMOS3 and this part is the drain. So these are the connected part that is already being connected. This drain has to be connected with the drains of the 3 NMOS since they were in parallel. So first connect this to VDD, middle click on M1, then middle click on M1, okay. Now these are the sources of NMOS. So select the area and then middle click on M1. Similarly over here, M1 and over here. These three are connected to ground. Okay, now VDD, these three are connected to ground. Now these three drain terminals, they are connected to VDD. So select the area and then middle click on M1. Then middle click on M1. This is M1. You can remove this part and then extend this since this is connected to the drain. Now this is the layout of a 3-input NOR gate. Now we have to place the contacts. So left click and right click, 4x4. This is the P diffusion contact, that is PD contact. We have one more PD contact, then the N diffusion contacts, that is the ND contact. over here also, then over here, the ND contact, then again a D contact. Now after placing the diffusion contacts, we have to place the substrate contacts. So this is the P substrate contact, one here, and okay. Now similarly the N substrate contacts, middle click on N substrate contact. Okay, now labeling, select a portion, right click, and then label VDD. This is ground, so label ground. Now these are the three inputs, that is A, B and C. So let's make some extension, middle click again, and one more. Since this is the output, middle click on M1, or we can just undo this. You can keep it over here. Okay, this is input A, so label VA. This is VB, and this is VC, and then the Vout. Okay, then the ground was already labeled. Okay, now save this as NOR 4 or NOR 3_3 1. Okay, now find the DRC errors. DRC find, no DRC errors. Then extract to spice, and then extract to sim. Once the sim file is being extracted, then type irsim NOR 3_1.sim. Then watch VA, VB, VC and Vout. Then display all are X. So if I give low value to all, then I'll get output as 1. This is output 1. If I give high value to any of the input, suppose let's say VA, then step, then I'll get value 0. Let's give high value to VC, then step, again 0. If high value to VB, step 0. If I do the reverse, low value to VA, others remaining 1, 0. Only when I give low value to all, I'll get the output as 1. If I want to see the final waveform, then type ANA VA VB, VC and Vout. So zoom to fit fill. At 0, 0, 0, output is 1, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, 0, 0, 1, 1, 0. Again when it's 0, 0, 0, 1. So only when 0, 0, 0, 1, that is what the truth table of NOR gate states. If you want to exit, type exit. If you want to see the layout again, then type NOR 3 underscore 1 dot mag so as to load the layout. So this is the layout of a 3 input XOR 3 input NOR gate.